The 902 also expects you to understand some concepts surrounding what we call the cloud. The cloud is a vague, nebulous term, in my opinion, that refers to computing done in a physically different location from where a user accesses a computing resource. When a user copies a photograph from his phone to his laptop, the computing resources he's using are in his possession. They're owned by him. It's local to him. When he uploads the photo to Snapchat or Facebook, that user is starting to use the cloud. While the cloud is a recent buzzword, in reality has been with us in one form or another since the beginning years of the internet. The most obvious example of a cloud service is email. As computing costs have come down, though, and especially now that cloud providers can make use of virtual computing, a wider variety of services can be offered and consumed by end users. Database products like Salesforce.com, infrastructure services like Microsoft's Azure and Amazon's AWS products allow users to set up and use computing resources that they would otherwise not be able to afford or not be able to build quickly enough for rapid consumption. Essentially, cloud computing revolves around a few essential concepts. One is that the process of accessing and using the service is largely self-service. There's no need to interact with anyone from the provider. The second concept is that the resource can be accessed by multiple platforms, phones, tablets, desktops, that sort of thing. Third, the service can be expanded quickly. That's the concept of rapid elasticity. And fourth, the provider's resources are pooled together to provide service to its customers. Finally, the use of the service can be measured and controlled. I'll go over those definitions again at the end of this presentation. We have 4 different deployment models for the cloud. Private is the first one. Services are provisioned and used by a single organization. Does not necessarily mean that the organization is building its own cloud, although it could. A third-party provider may be offering the services as well. So what does that mean? You might be in a business, we'll say a moving business, that uses a particular custom application for move management. And that is an application that is going to bring together the scheduling for the truck and the scheduling for the movers, coordinating with the customer who is being moved, and that sort of thing. Not necessarily something that you want to be facing the customer. You don't want the customer necessarily have access to this information or this process or this application. So that's a private cloud. You put that up on the cloud, and your employees who are involved with the move management access that resource and manage the move for the customer. Public models here. The services are provisioned for use by the general public. So now you're putting an application out on the cloud that people can consume, and this might be in the move with the mover business. What you would have is a move request type of software where you go in, you fill out a form that says you want to move on such and such a date. You want to move from this location to that location. Here's some special things that you need to worry about. Are you moving guns from one location to another? That opens up a whole different can of worms there. Various other things that you need to keep in mind when you're setting up a move but you need your customer to be able to access that computing resource. You put that on a public cloud. Community cloud services are provided for a specific community that have shared concerns and computing requirements. And then you have the hybrid cloud deployment model. Services are built on an infrastructure that is a composition of two or more cloud infrastructures. So what did I just say there? Your moving application, your move request application that you put on the public cloud that people can access to, when the person submits that, the request might go to a salesperson. The salesperson will call the customer, sign whatever contracts, collect whatever deposits they need, check off whatever they need to check off, make sure that they have all the concerns that the customer would have about the move are addressed. Then that salesperson gathers all that information and starts putting it through a business process where it goes to move management. From move management, it might go into an operations desk that sends the guys out to do the moving. And then from there, when everything is done, you of course have to bill the customer and collect his money. All that stuff is going to be on the private cloud, using resources that you don't want your customer to necessarily have access to. That's sort of a model there where the data is moving from public to private deployment models. You also need to be familiar with the cloud service models, SaaS, PaaS, and I don't know how to pronounce that. We'll call it YAS. SaaS, SaaS, software as a service. The cloud provider is providing applications for consumer use on a cloud infrastructure. There is little or no control on the consumer's end. Perfect example of this might be email. You're using private email like Hotmail or Gmail or Yahoo. You don't worry about making backups. You don't worry about setting up the DNS records for your email servers. You don't worry about provisioning storage space. You just use your email. And that is provided to you by a provider. Another example might be something like Salesforce.com, which is sort of a customer management solution. They have other solutions as well. A small business owner might use an online version of Quicken or some other type of accounting software. He doesn't have control, this individual does not have control over anything that goes on. He just goes in, puts in his information, saves it, and then comes back to it and works on it again on another day. The customer's not worried about backups. He's not worried about what servers are on it or the application is on. He is not managing anything other than the data that he is putting up there. In other words, the infrastructure and the platform are provided to him and the application as well. Going to PaaS, platform as a service. The cloud provider provides infrastructure services, but has no control over the underlying infrastructure. That's servers, firewalls, load balancing, and so on. So what did I just say there? You go back to that move management that I talked about earlier, the moving company. How would it use the cloud? It might use the cloud as just a way of accessing its own private application. So the application that we talked about with the customer-facing thing that creates the move request, that's an application that we'll put out onto the cloud. We have to manage all the code. We have to manage all the data that comes through there. But we are not managing the servers that are on there. We are not managing the firewalls that are on there. We are not managing any load balancing that might be involved. So load balancing is where you have multiple physical servers that are having traffic distributed to them by a load balancer. And the load balancer is what would be customer facing in this situation. So the request comes to the load balancer, say on port 443, the HTTPS TCP port. And then the load balancer will have a pool of servers that all have copies of the application on it. And we'll say it has 4, and as requests come in, it will shoot off the request to server 1, and then server 2, and then server 3, and then server 4, and so on and so forth. And as users sign off and no longer use it, they'll use a particular physical server. A request will then get balanced back over there. So everybody, all of the servers in that environment offering that service have roughly an equal number of users consuming that compute resource. IaaS or YaaS, infrastructure as a service. The cloud provider allows user control over the infrastructure, resources, and components. Servers, at least virtual servers, probably not the host servers. Firewalls, load balancing, and so on. A user who might use infrastructure as a service might be a larger provider, a huge insurance company, a government agency. This is probably something that, well, I was going to say Amazon, but Amazon is a cloud provider. Bad example. We'll go with eBay. They don't want to manage the most of the physical infrastructure, but they do need to have some control over there in case something becomes very popular, a service of theirs becomes very popular, and that sort of thing. I'll get into that in a little bit more detail when we talk about cloud essential characteristics. This is something we already went over. I just want to make sure you understand the definitions of what we are talking about. On-demand self-service. The customer can unilaterally provision computing resources without going to the cloud provider. In other words, they can go to the website, say they want to roll out a new application, and they will create the load balancing that they need and configure the servers the way that they need to be configured in order to act as platforms for the application. And once they click submit or whatever it is they need to click, that those resources are automatically there and ready to use. Broad network access. You can reach your application and service wherever the customer is and whatever device they might have. Resource pooling. The provider pools computing resources to provide the service to the customer. Rapid elasticity, and this is the thing that I was referring to when I was talking about infrastructure as a service. Rapid elasticity is, I might have sounded a little skeptical about the cloud earlier, but this is one of the genuine benefits of the cloud, in my opinion. Rapid elasticity. Let's say you're an insurance provider, and in a couple of days, you know that the hurricane is probably going to come through Georgia, Florida, somewhere down there. At the same time, a storm front is coming through, and you know that there's going to be tornadoes in Kansas. There's going to be hailstorms in Nebraska. And just for grins and giggles, we'll throw in fires in California. So you have all these disasters, and you're an insurance company, and you're insuring agricultural businesses out in California, wind farms in Kansas, and beachfront property and autos in Florida, you get the idea. You're going to take a hit when all this stuff happens and over the course of the next couple of days. And that hit is going to be huge spikes in traffic. Your customers are going to be making claims at a rate that you probably haven't seen before. Since we have some anticipation, we know a hurricane is not going to magically appear off the coast of Florida. We know we can see it approach. A day or two before it hits, the director of IT for that particular insurance company might say, okay, let's take our applications and right now say the claims applications are serviced by a load balanced pool of 20 servers. And that handles normal traffic with some normal spikes, over the course of the year. We might want to double that. So I have to be able to go to a cloud provider and just automatically provision. We need 20 virtual machines, 20 servers, configured in such and such a way. When I click submit, boom, 20 are there. 20 of those 20 servers are there and ready to go. And we can start loading up our applications onto those servers. And then when all these disasters happen, and in a couple of days after that, over the course of the next couple of weeks, people go online to file claims, we are able to handle the traffic that comes in. That's very important. You don't want your customers who are now without cars, who are now without homes, who are now without businesses, to not be able to access their claims for the insurance. They are going to be in a bad place and they need help. And the rapid elasticity characteristic of the cloud allows us to provide services without them seeing that, without them not being able to get through. That makes for, if you're the end user there, you're not happy. And if you're not happy, you're more likely to leave that insurance company and go to somebody else who can take that type of traffic spikes. And then the last thing there with the cloud essential characteristics is metered service. To go back to rapid elasticity and bring it into the metered service definition, you're measuring the services that are being used. So if you had to suddenly create those 20 servers and you used them for, we'll say for a month, all those disasters have passed, things have relaxed, the fires are out, the hurricane is gone, the hailstorm is no longer there, the tornadoes have gone away. Now you can dial down and get rid of all those servers that you created. There's no need for them to be there. So your rapid elasticity you contract your network there, and then you get billed appropriately for the resources that you used. And then when you no longer need them, you no longer get billed for those resources. That's kind of nice.